Hello, this is John from Team Spotter. You know, the hardest part of working out isn't always the weight you're lifting, it's the weight. Every time you stop mid-set to unlock your phone and log what you just did, you lose focus. And that's the problem we want to fix. Spotter AI steps in as a quiet partner. You just say, Spotter, bench, 185, 8 reps, and it's logged. No scrolling, no tapping, no breaking of the rhythm, just complete focus. Our goal is simple. Make progress tracking effortless and distraction-free. The vision is summed up best in one line. Let training feel like training again and not data entry. To show you how Spotter AI actually fits real people, we built several user stories, but these are the two that encapsulate the demographic. First, there's Elisa, age 52. She's a seasoned gym goer who values simplicity and clarity. She just wants clean feedback, her progress, her numbers, without clutter or distractions. And Spotter AI does that automatically. Then there's Malik. He trains almost daily, chasing performance gains. He wants to hop out of the gym. He doesn't want to stop to log sets. He just wants to call them out and look at his feedback. With Spotter AI, his data is captured mid-motion, hands-free, without breaking his flow. These two stories capture what we're really building towards. A system that adapts to different types of users but keeps the same promise: effortless tracking with no distractions. This next slide shows how we divided the development work and kept everything connected. Hussam handled the Agile and Scrum, coordinating sprints, distributing tasks, and keeping our workflow on track. Nasir took charge of architecture and design, building the cloud-backed mobile structure and managing our Git-based version control and continuous integration and development pipeline. Evan defined the core user problem, refined our target audience, and integrated the cross-platform React Native framework into design. Brandon focused on security, developing our privacy and authentication plans, and also built out our testing strategy for unit and integration testing. And my role centered on leadership, keeping communication open, maintaining consistency across all sections, and making sure everything came together cleanly from architecture to presentation. Now, I'll hand it over to Evan to walk through our vision refinement and detailed design.
For my part of the project, I focused on refining the core vision for Spotter and building out the detailed design. I defined the main problem, which is how manual tracking interrupts workouts, and identified our target users as fitness-minded people who wanted a simple, hands-free experience. And I also created the technical design for how the app works, including the voice interaction system, the workout tracking engine, and the progress insights. Overall, my contribution helps shape how Spotter functions and how it delivers a smooth, voice-driven experience.
Let's walk through our agile and sprint planning approaches. For our Scrum team, we have John as the product owner since he was the main inspiration for this idea, and he's responsible for defining the vision and feature backlog for Spotter. For our developers, who are the backbone of the implementation, we have Nasir, Brandon, and Evan. And finally, we have me as a Scrum Master who oversees the entire process and makes sure that our developers face no issues. We operate on 2-week sprints where we select high priority items that fit our capacity for that timeline, which results ultimately in a committed sprint backlog and a clear sprint goal. We use story points instead of estimated hours due to its ability to model the complexity, volume, and risk of each task. We use a Fibonacci sequence for our scale, and we try to achieve somewhere between 35 to 40 points for each sprint.
Spotter AI's architecture design follows a local-first approach with Cloud Sync for privacy and offline compatibility. Our system consists of several key components. On the mobile side, we have our React Native app, that provides the user interface across iOS and Android. We use on-device speech-to-text with Apple Speech on iOS and Google ML Kit on Android. All data lives in a local encrypted SQL database. Our command parser and intent engine handle voice interpretation, while our sync engine manages batching and conflict resolution. On the cloud side, we have Firebase as our backend and an admin dashboard for analytics. Now let's look at the data flow. A user speaks a command like bench 18548. Our on-device speech-to-text converts that audio to text with no audio stored. The command parser extracts the exercise, reps, and weight from the text. This structured data is immediately saved on our local encrypted storage, ensuring offline functionality. When the device is online, our sync engine uploads changes to the cloud. Finally, the UI dashboard shows workout history, charts, and progress metrics, all reading from the local database for fast performance. For our cloud infrastructure and security, we use Firebase Auth for sign-in, supporting both Apple and Google authentication. Workout data syncs to Firestore, and we use Cloud Functions for analytics, weekly summaries, and device synchronization. Security is paramount. No persistent audio is ever stored. All communication is TLS secured, and payloads are encrypted end-to-end. This architecture prioritizes user privacy, ensures full offline functionality, provides seamless cross-device synchronization while keeping infrastructure costs low during our MVP and growth phases.
With this project, we're going to have to address several important security and privacy considerations. First, we must decide how user data is stored and ensure that privacy is preserved. To minimize risk, we will not be saving any voice recordings, and we'll also rely on secure authentication methods to protect user accounts. We will also avoid handling sensitive payment information directly by delegating all payments to trusted platforms such as Apple App Store or Google's Play Store. In addition, we must maintain strong API and backend security and consider how the offline mode will interact with the system, particularly when data is being synchronized once the device reconnects. All third-party libraries are going to have to be vetted to ensure that they meet our security and privacy standards. And finally, we're going to have to provide transparent privacy settings that explain how the user's data is used and give them the ability to delete their data at any time. For our testing plan, the point is to ensure that the goals of the app are met and they're tested to a degree that meets our standards. To do so, we're going to be using a couple different types of testing. Included would be unit testing, which is making sure that each of the programs work individually. Integration testing is making sure they work together. And then end-to-end is that we are going to be testing as if one is the user. To do so, we are going to be doing performance and load testing, device and environment testing. We're going to be doing accessibility testing, and then finally security testing as well. All of these will be split into Sprint 1, Sprint 2, and post-release. And then within the report, we have specified criteria that we must meet in order to have completed the app.
Let me walk you through the DevOps practices we've established for Spotter AI, built on three core pillars: version control, automated CI/CD, and monitoring with security. We maintain a shared GitHub repo, or we use a feature branch workflow where developers create feature branches, push changes frequently, and pull requests for review. Every pull request requires peer review. GitHub Actions runs automated tests on every pull request. Our CD pipeline handles deployment automatically. For monitoring and security, Firebase Crashlytics tracks crashes and performance in real time. We collect analytics on feature usage, but zero personal data. No transcripts or workout content is ever transmitted. And all API keys and tokens are stored in GitHub secrets and Firebase environment files, never on our code base. These practices ensure code quality, fast deployment, and robust security.
Spotter AI showcases multiple advantages over other fitness trackers in the industry. These advantages include hands-free voice AI compared to manually typing, one-time purchasing models compared to recurring subscriptions, and increased focus due to the reduced screen distractions. By reducing the screen usage during workouts, we transform fitness tracking from a distraction into a convenient assistant. This preserves the user's flow state and improves training intensity. In terms of feasibility, we have low technical risks since our proposal leverages APIs that are mature rather than building models from scratch. And economically, it is sustainable due to the utilization of on-device processing that significantly reduces cloud costs and validates our one-time pay model.
To wrap things up, Spotter AI was built around one simple goal: to help people train without distraction. At its core, it's about focus, keeping users engaged in their workouts by eliminating the constant interruptions of manual logging. Through innovative design, we blended voice AI technology with a simple, intuitive interface, giving users a seamless experience that feels natural and efficient. None of this would have come together without the collaborative development. Each of us contributed to different parts, from architecture to testing, using agile principles to keep every piece moving and in sync. And ultimately, our vision stays clear: to empower users to train freely, track progress effortlessly, and turn fitness into something enjoyable again. Thank you.